mankind and its fast-moving behaviors, the motion that keeps the cycle of life running. But this motion is driven by various energies which act as the fuel that keeps it running without any hassles. There are various forms of energies that keep us moving in the daily life. One such important form of energy is electricity, the most powerful gift given by the nature to the mankind. But this intense power energy needs to be controlled to make our life smooth and running. From locomotives to household distributions, from industries to high-power electrical plants. It's the job of various high-powered semiconductor devices to control the flow of electricity, with diodes, thyristors, modules, and bridges. And the job of manufacturing such high-power semiconductor devices and other equipments is successfully accomplished by one of the leading players in this field, Ratan International Rectifiers Limited. Ratan International Rectifiers Limited is today the pioneer in the line of manufacturing high-power semiconductor devices such as diodes, thyristors, modules, rectifier assemblies, traction rectifiers, electrochemical rectifiers, and battery chargers. These devices play a very important role by controlling the energy that we consume in our day-to-day life, which includes the railways, power backup systems in corporates, battery chargers, and power generation industries. With an advanced research-based silicon technology, Ratan International Rectifiers has today grown up to the mark of achieving a well-sufficient setup for manufacturing a wide range of multi-segmented devices and equipments used in various industries. Today, Ratan International Rectifiers Limited has the capability of manufacturing start-to-end products, right from small silicon wafers to high-power industrial equipments. With an in-house research and development backed by its USA-based associate, Measures Silicon Power. Today, Ratan International Rectifiers Limited has formed the monopoly in the private sector markets of the electrical industry. Let's have a look at the manufacturing processes. The manufacturing of such high-power semiconductor devices basically involves the following set of processes: lapping, diffusion, photolithography, alloying, evaporation, passivation, encapsulation, epoxy filling, and final testing. Raw silicon wafers of different thickness ranging from 400 to 1500 microns and diameters ranging from 38 to 150 millimeters are imported. They are then lapped to achieve the required thickness as per the specifications. This is done either by a single-side or double-side lapping machines, with the help of a slurry of abrasive power. Diffusion is a process in which the dopant, either P-type or N-type, are diffused in silicon up to the desired depth by subjecting the wafer to an elevated temperature ranging between 900 degrees Celsius to 1200 degrees Celsius. Ratan International Rectifiers Limited has the facility to diffuse chips up to 125 mm and being expanded up to 150 mm. Photolithography is a process in which various patterns are defined on the surface of silicon wafer by photolithographic process. Layers of photoresistant materials are first spin-coated onto the wire substrate. Next, the resistant layer is selectively exposed under the ultraviolet light. An exposure tool and mask are used to effect the desired selective exposure. The pattern in the resistant is formed when it is developed by the developer. After generating the pattern on the wafer, the unprotected area are chemically etched, and finally all the resistant is removed from the wafer by cleaning them in plasma etching. Alloying is a process in which the silicon wafer is alloyed with molybdenum or tungsten discs with the help of aluminum silicon discs at the temperature of 720 degrees Celsius under a high vacuum system. The alloyed silicon chip is called the junction. In this process, the cathode side of the junction or the alloyed silicon chip is plated with 15 to 20 micrometer thickness of aluminium by evaporation technique. The evaporation sew-down is by thin film technology. Substrates are loaded into the rotatory planetary system inside the high vacuum chamber. The source aluminium is melted with the help of electron beam power supply and it starts to evaporate and deposit on the substrate. After completion of the etching of the junctions, if they withstand required voltage under high vacuum, they are coated with photonese and RTV successively on the peripheral. After coating the junctions securely in oven for 300 degrees Celsius for particular hours. Photonese and RTV are insulating materials. They give better voltage blocking, stability under maximum operating temperature of the device. It also protects the junction from mechanical damage. The tested junctions are then assembled in a ceramic housing and hermetically sealed by the cold well equipment under specific conditions and become finished device for further testing and final inspection. In case of modules and bridge rectifiers, junctions are assembled inside an insulated housing and filled with epoxy resin. Finished devices are then finally tested for leakage and all other electrical, mechanical, and thermal parameters. The firm policies in the practice of product manufacturing and quality control is the essence of remarkable growth of Ratan Shah International Rectifiers clientele and their appreciations. Ratan Shah International Rectifiers Limited have achieved a year-after-year growth in its financial performance due to its increasing sale of products and fast-growing relationships with its customers. Ratan Shah International Rectifiers Limited constantly strives to maintain its position in terms of customer satisfaction and its mutual growth with its associates.